The cosmos is not a still painting but a theater of the bizarre. Right now, as you watch this, events of unimaginable scale and strangeness are unfolding across the darkness. Galaxies are being pulled by unseen forces, stars are preparing to explode, and mysteries older than time itself are playing out in real time. By the end of this journey, you will witness 25 of the most astonishing cosmic happenings that are actively reshaping our understanding of reality. We will visit a void so vast it defies logic and listen for signals that might not be natural. What single cosmic mystery do you find the most compelling? Our galaxy is in motion, but not in a way you might expect. We are not simply orbiting the center of the Milky Way. We are being pulled, along with every star and planet around us, on a collision course with a cosmic mystery. Somewhere in the distant constellation of Centaurus, a gravitational anomaly known as the Great Attractor is reeling us in. Right now, our entire galactic neighborhood is streaming toward this unseen point at a staggering speed of over 14 million miles per hour. It is a silent, relentless tug of war happening in the present moment, and we are on the losing team. The force required to move thousands of galaxies, including our own, is incomprehensible. Scientists first realized something was wrong when they mapped the cosmic microwave background, the afterglow of the Big Bang. They found a vast river of galaxies all flowing in the same direction, like leaves caught in a drain. The source of that current is the Great Attractor, but what is it? Our best guess is a supercluster of galaxies, a dense knot of normal matter, but that does not fully account for the sheer gravitational muscle on display. The leading theory points to an immense concentration of dark matter, the invisible glue of the universe acting as a cosmic anchor, yet even that may not be the whole story. Some speculate it could be something far stranger, a structural flaw in the fabric of spacetime itself. Making this mystery even more profound is our inability to see it directly. The Great Attractor lies hidden behind what astronomers call the zone of avoidance. This is not a mystical barrier, but a thick lane of interstellar dust and stars right in the plane of our own Milky Way. It acts like a cosmic blindfold, obscuring our view of the universe beyond. We are essentially trying to identify a distant mountain peak while standing in a dense fog. All we can do is measure its gravitational influence, feeling the pull without seeing the hand. So as you go about your day, remember this: you, your home, your world, and every star you see at night are passengers on a ship sailing toward an unknown destination. We are caught in a river of galaxies flowing toward a shadow in the sky, and we still do not know what awaits us at the end of the current. While we are pulled toward an unseen future, another star in our own cosmic backyard is writing its final, unpredictable chapter. Look up at the constellation Orion, at the brilliant red star marking the hunter's shoulder. That is Betelgeuse, a colossal red supergiant so vast that if placed at the center of our solar system, its surface would extend past the orbit of Jupiter. And right now, it is behaving very, very strangely. In late 2019, astronomers watched in stunned silence as this familiar beacon of the winter sky began to fade. Over the following months, Betelgeuse dimmed dramatically, losing nearly 2/3 of its usual light. For a star of its type, this was not just unusual, it was unprecedented. The internet erupted with a single, thrilling question. Was this the final act? Was Betelgeuse, a star clearly in the final stages of its life, about to go supernova? The possibility was not science fiction. When a star of this mass dies, it does not go quietly. It collapses in on itself in a cataclysmic explosion so powerful it can outshine an entire galaxy. For a few glorious months, a new point of light, brighter than the full moon, would appear in our daytime sky. Night would briefly become a soft twilight, and the star would be visible to the naked eye even at noon for weeks. But then, Betelgeuse brightened again. The immediate panic subsided, replaced by profound curiosity. The Great Dimming was not the supernova, but something perhaps just as fascinating. Analysis revealed the star had likely coughed out a colossal cloud of dust, a cosmic sneeze that temporarily veiled its light, yet the mystery only deepened. Betelgeuse is a variable star, meaning it naturally pulses in brightness, but its rhythms have become erratic, irregular. Astronomers are now monitoring it in real time with a network of telescopes watching every flicker and sigh. Each irregular pulse could be a sign of the internal turmoil that precedes a titanic explosion. The truth is, we are watching a stellar countdown with no visible clock. The final collapse could happen tomorrow, or it might not happen for another 100,000 years. We are witnessing the final, unstable years of a cosmic giant, and we have front-row seats. So the next time you see Orion in the night sky, take a moment to look at that red dot. You are looking at a dying star, a cosmic time bomb whose fuse length is unknown. Its light, which has traveled 640 years to reach your eyes, is a message from the past telling us that in the present, anything is possible. The death throes of a nearby star are a local spectacle, but the true scale of cosmic emptiness dwarfs even that drama. Drift away from our galactic neighborhood, past the local group, and journey toward the constellation Boötes, the herdsman. There you will find nothing, not just a dark patch between stars, but a staggering sphere of near-total nothingness, a hole in the universe itself. This is the Boötes void, a region of space so profoundly empty it defies comprehension. Stretching an incomprehensible 330 million light-years across, this cosmic cavern should, by all our models of the universe, contain tens of thousands of galaxies. Instead, astronomers have found only a scant few dozen, lost like lonely islands in an ocean of darkness. If our Milky Way were at the center of this void, we would not have known other galaxies existed until the 1960s. The sheer scale of this emptiness is not just surprising, it is a direct challenge to everything we think we know about how matter clumped together after the Big Bang. Our standard model of cosmology paints a picture of a universe with a web-like structure, a great cosmic net where galaxies form along dense filaments with smaller, emptier bubbles in between. The Boötes void is not a bubble, it is a chasm. It is so vast that its existence suggests our understanding of that large-scale structure might be incomplete, or that something extraordinary happened here in the primordial universe. So what could carve out such a nothingness? One leading theory is simpler than it sounds, the idea of a void within a void. Imagine blowing soap bubbles where smaller bubbles merge into one gigantic one. The Boötes void might be the result of many smaller cosmic voids merging over billions of years, creating one ultimate supervoid. Yet even this merging process struggles to account for the sheer, staggering scale of the emptiness we observe. This leads to more exotic possibilities rooted in the universe's first moments. Tiny quantum fluctuations, random ripples in the fabric of reality that were magnified to cosmic size during a period of hyper-fast expansion called inflation, could have planted the seeds for such a void. It might be a fossil, a single inflated quantum bubble frozen into the architecture of the cosmos. Studying this void is a unique window into both the ancient past and the present. The light from the few galaxies within it, and from the distant wall of galaxies far beyond its far side, has been traveling for hundreds of millions of years. We are seeing it as it was in the deep past, yet because the void is so immense, that ancient light is also telling us about the structure of the universe in our present era. It is a ghostly imprint of the universe's infancy, still visible in the sky tonight. This vast cosmic desert is not just empty space, it is a profound question mark written in darkness, forcing us to wonder what other immense structures or absences lie waiting in the unseen depths. Amidst such vast cosmic emptiness, the universe also crackles with sudden, brilliant screams of energy. Scattered across the deep sky, invisible to our eyes but screaming across radio frequencies, are events known as fast radio bursts. These are not gentle signals, they are the universe's most powerful and enigmatic flashes, packing more energy in a single millisecond than our sun emits in 80 years. And they are happening right now, all the time. New ones are being picked up by our most sensitive telescopes almost every week, each one a brief, violent shout from a source billions of light years away. For years, every burst was a one-off event, a cosmic flash in the pan that left astronomers scrambling to explain what could possibly destroy itself with such ferocity. Theories ranged from the collision of ultra-dense neutron stars to the final, catastrophic evaporation of a black hole, but then everything changed. We found one that talked back, a source now famously known as FRB 121102 did something extraordinary. It repeated, not on a schedule, not with a rhythm we could predict, but in unpredictable clustered outbursts. This was a revolution. It meant the source was not destroyed in the blast. Whatever engine was powering these bursts was capable of firing again and again, surviving its own apocalyptic fury. This single discovery shifted the entire investigation. The leading suspect now is a type of stellar corpse called a magnetar. Imagine a neutron star, a city-sized ball of matter so dense a teaspoon of it would weigh 1 billion tons, but then twist its magnetic field to unimaginable strength. A magnetar's magnetic field is a quadrillion times more powerful than Earth's. A starquake on its crust, a sudden snapping of these magnetic fields, could theoretically unleash a focused blast of radio waves powerful enough to cross the universe. It fits the profile of a repeating, surviving source. Yet, the sheer power and bizarre patterns of some bursts keep other ideas on the table, including the most tantalizing and speculative of all. Could these be signatures of advanced technology? A civilization might use a focused burst of this magnitude to power light sails for interstellar travel or as a cosmic lighthouse. While this is the least likely explanation scientifically, it highlights just how extraordinary these signals truly are. The real story is the global, real-time detective work underway. From the sprawling dishes of the CHIME telescope in Canada to arrays across the world, astronomers are now catching these bursts in the act, triangulating their galactic addresses and searching for any other signal, like X-rays or visible light, that might accompany the radio scream. Each new detection is a piece of a puzzle we are only beginning to assemble. So while you listen to the radio in your car, remember that another kind of broadcast is slicing through the void. Each one is a postcard from a distant, violent event, a millisecond of cosmic chaos that challenges our understanding of physics itself, and the detective story to decode them is unfolding live. While we listen for radio screams, a different kind of cosmic monster is on the loose. A supermassive black hole, an object with the mass of 20 million suns, has been caught in the act of fleeing its home galaxy. It is not drifting silently through the void, but blazing a path of creation in its wake, a bizarre contradiction that is rewriting the rules of cosmic behavior. The Hubble Space Telescope captured the evidence, a brilliant, almost straight trail of young, blue stars stretching an astonishing 200,000 light-years across space. It looks less like a path of destruction and more like a cosmic contrail, a ribbon of newborn suns left behind by a gravitational titan in flight. This is not a relic of the ancient past. The light we see tells us this event is unfolding in what we consider the present cosmic era, a dramatic process happening right now. The leading theory for this incredible escape involves a gravitational slingshot of unimaginable power. When two galaxies collide, their central supermassive black holes eventually sink to the merged galaxy's core, beginning a slow orbital dance. As they spiral closer, they fling stars away through complex gravitational interactions. If a third black hole is introduced into this chaotic system, the resulting three-body gravitational tango can become violently unstable. One of the black holes can be ejected at tremendous speed, like a stone from a sling, catapulted out of the galactic core entirely. This runaway behemoth, still surrounded by a dense cloak of gas from its former home, is what we may be witnessing. As it hurtles through the thin gas that exists between galaxies, this material is compressed and shocked in front of it, triggering sudden, intense bursts of star formation in its wake. It is a cosmic paradox, a destroyer of worlds acting as a forced midwife for new ones. The very gas it terrorizes is squeezed into becoming stellar nurseries. This discovery provides a stunning live-action view of the aftermath of galactic collisions. It shows us that the mergers of galaxies are not tidy, gentle affairs, but violent reorganizations that can literally kick the hearts of galaxies out into the intergalactic wilderness. Simulations of these chaotic mergers show the precise conditions needed for such an ejection, and now we have what appears to be the real-world evidence. This single, streaking trail of stars is a forensic clue to a cataclysm that happened long ago, yet its effects are still visibly painting the cosmos today. So we are left with the image of a runaway giant, a gravitational fugitive forging a new path of light through the darkness, a permanent scar, and a brilliant creation born from a single, catastrophic kick. The universe's rogue black holes forge new stars, but other cosmic lights are being stolen before our eyes. One star in particular, known as Tabby's star, has become the poster child for celestial mystery. Officially catalogued as KIC 8462852, this otherwise ordinary star in the constellation Cygnus does something extraordinary. It dims not in a gentle, predictable rhythm like a planet passing in front of it, but in dramatic, jagged, and completely irregular plunges of light. At times, its brightness has dropped by a staggering 22%, a depth that means something enormous is blocking its light. A Jupiter-sized planet would only cause a 1% dip. Whatever is orbiting Tabby's star is not a planet. It is something else, and its strange performance is still ongoing, with new dimming events recorded as recently as the past few years. The initial data captured by the Kepler Space Telescope showed a light curve that looked broken. Instead of clean, symmetrical U-shaped dips, the graph was a chaotic series of cliffs and valleys with drops of different depths and durations. It was so bizarre that one of the first explanations to capture the public's imagination was the idea of an alien megastructure, a vast swarm of solar collectors known as a Dyson sphere under construction. While a thrilling thought, science has since followed the evidence toward more natural, yet still profoundly strange possibilities. The leading theories now focus on cosmic dust and debris. One compelling idea involves a giant, fragmented swarm of exocomets, the remnants of a catastrophic collision in the star's system. This immense cloud of icy and dusty fragments on wildly eccentric orbits could pass in front of the star in clumps, creating the irregular, deep dimming patterns we see. Another explanation points to circumstellar dust, a thick, uneven ring of fine material orbiting the star itself. Crucially, follow-up observations found the dimming is more pronounced in infrared light than in visible blue light. This is a key fingerprint of dust, as tiny particles scatter blue light more effectively, letting more red and infrared light pass through. A solid megastructure would block all wavelengths equally. So the alien megastructure hypothesis has largely been set aside, but in its place is a mystery just as captivating. What event could create such an immense, chaotic swarm of dust? Was it a planetary collision of apocalyptic scale? Is the star itself behaving erratically, belching out vast clouds of material? The data continues to roll in from observatories around the world, each new dip in the light curve adding another piece to a puzzle that refuses to form a clear picture. We are left watching a cosmic detective story in real time, where the suspect is a cloud of dust, but the crime scene defies all expectation. The strange dimming of a single star is a local puzzle, but some cosmic mysteries are so vast they defy any sense of scale. Recently, radio telescopes mapping the sky have stumbled upon structures that should not exist. ghostly rings so immense they could swallow our entire Milky Way galaxy whole. Astronomers have named them odd radio circles, and their discovery has sent a ripple of genuine bewilderment through the scientific community. Each ORC is a perfect or nearly perfect circle of radio wave emission, a faint but distinct halo hanging in deep space. They are not visible in optical, X-ray, or infrared light, only in the specific frequencies that radio telescopes can detect. This means they are not made of stars, but of something else, something that whispers to us only in this one silent language of the cosmos. And they are not relics of the ancient past, they are features of our present-day universe, meaning whatever created them is either a recent event or an ongoing process we do not yet understand. The sheer size of these circles is the first clue to their profound strangeness. A typical ORC spans about 1 million light-years across. To put that in perspective, if one were centered on our galaxy, its outer rim would reach halfway to our great galactic neighbor, Andromeda. Entire galaxies sit at the hearts of some of these rings, looking like tiny jewels set in a gargantuan, invisible band. This scale immediately rules out most common explanations. They are not the remnants of a standard supernova, nor are they the typical lobes of radio emission produced by active black holes. They are something entirely new, a class of object we did not even have a name for until a few years ago. So what could possibly carve such perfect, titanic rings into the fabric of space? The theories are as wild as the objects themselves. One leading idea suggests they are the shockwaves from a truly galactic wind. Imagine two galaxies merging, their central supermassive black holes feasting on gas and blowing out colossal, spherical bubbles of energetic particles at nearly the speed of light. If we are looking at such a bubble edge-on, it might appear as a crisp, circular ring. Another, even more dramatic possibility is that they are the aftermath of a stupendous explosion, perhaps triggered by the merger of two supermassive black holes. Such an event would unleash a spherical tsunami of energy that could propagate outward for eons, leaving a fading radio echo in the shape of a perfect shell. Then there are the more exotic suggestions, ideas that venture to the very edge of known physics. Could these circles be the throats of wormholes, theoretical tunnels through space-time, as seen from a certain angle? Or are they the imprints of collisions between our universe and another bubble universe in the vast cosmic foam of a multiverse? While these are less likely, the fact that they are even being seriously discussed highlights just how baffling the ORCs truly are. The most compelling clue is that they are being found now because our radio telescopes have finally become powerful and sensitive enough to see them. They were always there, hidden in plain sight, waiting for our technology to catch up to their subtle signal. New ORCs are being identified as surveys continue, each one a fresh data point in a mystery we are only beginning to map. We are witnessing the birth of a new field of astronomy in real time, a reminder that the universe still holds enormous surprises, written in rings of radio light on a scale we are only just learning to see. While ghostly radio circles hang in the void, other cosmic objects are making a much more violent exit. Some stars are not content to orbit peacefully within the Milky Way, they are running away. These are hypervelocity stars, stellar projectiles moving so fast that the gravitational pull of our entire galaxy cannot hold them. Right now, stars like the one catalogued as S5HVS1 are screaming through the darkness at speeds exceeding 1 million miles per hour on a permanent one-way journey into the great nothing between galaxies. To be flung from our galaxy, a star needs a truly monstrous slingshot. The prime suspect sits at the very heart of the Milky Way, the supermassive black hole known as Sagittarius A star. Astronomers theorize that most hypervelocity stars begin their lives as part of a binary pair, two stars orbiting each other closely. If this doomed duo drifts too close to the galactic center, the black hole's immense gravity can tear the binary apart. One star is captured into a tight orbit around the black hole, while its companion is violently flung outward like a stone from a giant sling, gaining a tremendous burst of speed from the interaction. This gravitational catapult can accelerate a star to velocities that defy belief, granting it a ticket to leave the galaxy forever. There is another, even more explosive origin story. In a binary star system where one star goes supernova, the sudden, asymmetric detonation can act like a cosmic cannon. If the exploding star blows off its outer layers in a lopsided way, the recoil can kick the surviving companion star clear out of the system at hypervelocity speeds, sending it careening through interstellar space. We are witnessing the aftermath of these stellar cataclysms in real time. The trajectory of stars like S5HV-S1 can be traced backward, and their paths often point directly back to the galactic center, implicating the central black hole as the likely culprit. Their journey is a lonely and epic one. A hypervelocity star will blaze through the sparse gas of the galactic halo, a faint stellar shroud surrounding the Milky Way's bright disk. Within 100 million years, it will break free entirely, crossing the threshold where the galaxy's gravity finally loses its grip. From there, it enters the intergalactic void, a sea of profound darkness where the nearest galaxy might be millions of light years away. It will travel alone for eons, a solitary beacon whose light will eventually fade into the endless black, a permanent exile from the stellar community it once called home. Each one is a testament to the violent, chaotic forces that sculpt our galaxy, a runaway piece of cosmic shrapnel from a battle with gravity itself. Our own galaxy is not the only one harboring a monstrous appetite. Gazing toward the constellation Andromeda on a clear night, you can just make out a faint, fuzzy patch of light. That is the Andromeda Galaxy, our closest major galactic neighbor, and it is currently devouring its own children. This is not a metaphor. Andromeda is a cosmic cannibal, actively tearing apart and absorbing smaller satellite galaxies that orbit it, a feast whose evidence is written across the sky. Through powerful telescopes, astronomers see vast, looping rivers of stars, delicate stellar streams that arc around Andromeda like the gossamer threads of a broken web. These are the remnants of dwarf galaxies, their structures stretched and shredded by Andromeda's immense gravity. Their stars are being siphoned away, slowly dissolving into the larger galaxy's outer halo, a process happening right now, over 2.5 million light-years away. This galactic digestion is a slow but relentless force of nature, and it serves as a stark preview of our own distant future. For Andromeda is not just consuming its satellites, it is also on a direct collision course with us. The Milky Way and Andromeda are caught in a mutual gravitational embrace, pulling each other closer with every passing second. In about 4.5 billion years, the two spiral giants will begin a slow, majestic, and inevitable dance of destruction and creation. What does such a collision look like? It is nothing like the explosive crashes we might imagine. The spaces between stars are so vast that actual stellar collisions are extraordinarily rare. Instead, the galaxies will pass through each other, their gravitational forces acting like tidal hands, twisting and warping their beautiful spiral arms into long, streaming tails of stars. Imagine two great crowds of people walking slowly through each other, their shapes blurring and merging rather than two cars smashing together. Over hundreds of millions of years, they will swing apart, then fall back together, finally settling into a single, massive, elliptical galaxy that astronomers have already nicknamed Milkomda. Within this new hybrid galaxy, the night sky from any surviving planet would be transformed. Instead of a familiar band of the Milky Way, the heavens would be filled with a dazzling, chaotic spray of stars, and the brilliant core of the merged galaxy would glow as a constant, luminous beacon. This future merger is not a speculative idea. It is a certainty measured by the precise blue shift of Andromeda's light, telling us it is moving toward us. We are watching a slow-motion car crash of cosmic proportions, a preordained event whose first act is already underway as Andromeda practices its merging skills on its smaller companions. So that faint smudge of light is both a beautiful island universe and a harbinger of a spectacular, distant tomorrow, a reminder that even the grandest structures in the cosmos are not permanent, but part of an endless cycle of gravitational interplay. The galactic cannibalism of Andromeda is a slow, majestic process, but not every object in the cosmos is bound to such a grand fate. Billions of worlds are utterly alone, adrift in the perpetual night between the stars. These are rogue planets, dark nomads untethered to any sun, and they are wandering the frozen depths of our galaxy right now. For every star you see in the sky, there could be thousands of these invisible, orphaned worlds. They are the cosmic homeless, born from chaos and cast out into the void. How does a planet lose its star? The journey to solitude is violent. Some rogue planets may form on their own from collapsing clouds of gas and dust, miniature failed stars never large enough to ignite. But most are likely the tragic casualties of gravitational turmoil within young solar systems. Picture a newborn planetary system, a chaotic disk of material where giant planets like Jupiter are jostling for position. A close gravitational encounter between two such giants can be catastrophic. One planet might be flung clear of the star's grip entirely, catapulted into interstellar space like a stone from a sling. In other scenarios, the death of a star itself can be the trigger. If a binary star system is torn apart by a supernova explosion, any orbiting planets can be sent careening off on their own uncharted path. The scale of this exile is staggering. Current estimates suggest there could be billions, even trillions, of these dark wanderers in the Milky Way alone, outnumbering the stars themselves. They are invisible to traditional telescopes, detected only by the fleeting, telltale microlensing event, a tiny brightening of a distant star as the rogue planet's gravity briefly bends and magnifies its light like a cosmic lens. Each detection is a statistical miracle, a glimpse of a single shadow in an ocean of darkness. Yet within that profound cold and blackness, a startling possibility emerges. Life, as we stubbornly imagine it, requires warmth and liquid water. A rogue planet far from any star has no external source of heat. Its surface would be a frozen wasteland only a few degrees above absolute zero. But deep beneath that icy crust, something remarkable could persist. The internal heat from radioactive decay in the planet's core, a faint leftover warmth from its formation, could be enough to maintain vast global subsurface oceans. Imagine a world with a shell of ice dozens of miles thick, shielding a dark, salty sea larger than all of Earth's oceans combined, kept liquid by the gentle geothermal glow from below. In that abyssal blackness around hydrothermal vents spewing minerals and warmth, life might not only exist but thrive, completely unaware of a universe filled with stars. Standing on the surface of such a world would be an experience of ultimate solitude. The sky above would be an unbroken tapestry of stars, crystal clear with no atmosphere to blur them, but there would be no sunrise, no daytime, no concept of a year. Just an eternal, frozen midnight, with the only light coming from the distant, unmoving galactic pinpricks above and the faint, cold glow of your own breath. You would be standing on a ship sailing a silent sea, destination unknown, with no lighthouse to guide you. These dark wanderers challenge our very definition of a habitable world, suggesting that life could be far more tenacious and far more lonely than we ever dreamed. Far from the lonely wanderers between stars, a different kind of shadow may be hiding within our own celestial backyard. At the very edge of our solar system, beyond the orbit of Neptune, the gravitational story is not adding up. Something is out there, a ghost in the gravitational machine, and we call it Planet 9. This is not a confirmed world, but a hypothesis born from the strange, clustered paths of the most distant icy objects we can see. Their orbits are not randomly scattered as we would expect, but are instead grouped together as if shepherded by an unseen hand. The mathematics points to a massive presence, a planet with up to 10 times the mass of Earth, tracing a monstrous elliptical loop around the Sun. If it is real, it is out there right now, a frozen giant lurking in the perpetual twilight, taking perhaps 10,000 to 20,000 years to complete a single, sluggish orbit. To put that timescale into perspective, the last time this hypothetical world was in our neck of the cosmic woods, human civilization was in its infancy and woolly mammoths still walked the Earth. The evidence is written in the paths of small, icy bodies in the distant Kuiper Belt. These objects, some with orbits that swing hundreds of times farther from the Sun than Pluto, should be oriented every which way. Instead, their closest approaches to the Sun, their perihelia, are mysteriously bunched together in space, and their orbits are tilted in a similar direction. It is as if you dropped 100 pencils on the floor and found they had all landed pointing northeast. The probability of this happening by random chance is astronomically low, suggesting a massive perturber, a distant gravitational anchor, is organizing them. This would be Planet 9, a world so distant that the Sun would appear as little more than an exceptionally bright star in its black sky, providing virtually no warmth. Its surface would be a frozen landscape of hydrogen, helium, and water ice, a perpetual winter world where temperatures hover near absolute zero. The hunt for this phantom planet is one of modern astronomy's great detective stories. Teams are using the world's most powerful telescopes, like Subaru in Hawaii, to scan vast, thin slices of the sky where orbital calculations suggest it might be hiding. They are looking for a single, faint point of light moving slowly against the backdrop of fixed stars, an incredibly difficult task given its predicted distance and dimness. Every new survey that comes up empty narrows the possible hiding places, refining the search. Finding Planet 9 would be a monumental discovery, an instant rewriting of every solar system textbook. It would confirm that our cosmic neighborhood is far larger and more dynamically complex than we ever imagined, with a hidden architect sculpting the fringes of our own domain from the shadows. Until then, it remains a tantalizing possibility, a gravitational whisper from the dark, reminding us that even in our own system, the final map may not yet be complete. The gravitational whispers of a hidden planet are not the only secret our galaxy holds. From its very heart, a pair of colossal, ghostly structures are erupting into space. Known as the Fermi bubbles, these are not made of gas or dust, but of pure, high-energy radiation. They form a perfect hourglass shape, with each lobe stretching an astonishing 25,000 light-years above and below the galactic plane. If our eyes could see in gamma rays, the highest energy form of light, the Milky Way would not look like a serene spiral, but like a violent, radiant hourglass suspended in the void. For a long time, these bubbles were invisible, hidden in plain sight. They were only discovered in 2010, when scientists painstakingly analyzed data from the Fermi Gamma Ray Space Telescope. By carefully subtracting all the known sources of gamma rays from across the sky, they revealed this immense, symmetrical glow centered on our galaxy's core. The discovery was a shock because these structures are not ancient, quiet fossils. They are the signature of a relatively recent and cataclysmic event, one that occurred just a few million years ago. In cosmic terms, that is like something that happened yesterday afternoon. The energy required to inflate such gigantic bubbles is almost beyond comprehension. It is equivalent to the simultaneous explosion of 100,000 supernovae. So what kind of cosmic engine could produce such a titanic, focused outburst? All evidence points to the sleeping giant at the center of our galaxy, the supermassive black hole Sagittarius, a star. While it is quiet today, the Fermi bubbles are proof that it was not always so serene. The leading theory is that several million years ago, Sagittarius, a star, experienced a violent feeding frenzy. A massive cloud of gas, or perhaps even a star, strayed too close and was torn apart by the black hole's gravity. But instead of swallowing all the material quietly, the black hole's intense magnetic fields and accretion disk funneled a fraction of the infalling matter into two powerful, opposing jets. These jets, moving at a significant fraction of the speed of light, punched through the galactic halo, inflating these vast bubbles of superheated plasma. Inside these bubbles, even now, electrons are being accelerated to near light speed, and when these relativistic particles collide with photons of lower energy light, they boost them up to the gamma-ray energies we detect. This means the event that created the bubbles is technically over, but its aftermath is still actively playing out, a fading echo of a galactic-scale scream. This changes our understanding of our galactic center entirely. It tells us that Sagittarius, a star, is not a permanently dormant monster, but a cyclical one. It has active periods, outbursts that reshape its environment on a galactic scale. Simulations of these black hole outbursts showed jets that exactly match the morphology of the Fermi bubbles, a perfect hourglass of energy. We are living in the quiet aftermath of one such eruption, looking up at the still glowing remnants of a past cataclysm. It raises a profound and slightly unsettling question. If this happened once, it can happen again. Our solar system is far from the galactic center, so we are in no direct danger from such an event, but it serves as a powerful reminder that the cosmos is not a static painting. Even the heart of our own familiar Milky Way is capable of sudden, violent awakenings, whose light takes millennia to reach the edges of its domain. That fading echo from our galaxy's heart is a reminder to listen closely. The cosmos is not silent, and sometimes it speaks in ways that stop you cold. On August 15, 1977, a radio telescope at Ohio State University known as the Big Ear was performing a routine sky survey. It was listening to the hiss of the universe, a background noise of natural cosmic processes. Then, for 72 seconds, the silence broke. The signal was a narrowband radio burst, focused on a frequency that natural cosmic objects almost never emit, a frequency that happens to be near a prime candidate for interstellar communication. It was so powerful that astronomer Jerry Amon, reviewing the computer printout days later, circled the alphanumeric sequence representing its intensity and wrote one word in the margin: wow. That single, unexplained shout from the constellation Sagittarius has never been heard again, despite dozens of follow-up searches. It remains the most tantalizing and frustrating candidate for a signal not made by nature. The original printout, with its circled letters and that famous exclamation, is a relic of a moment when the universe seemed to whisper hello. But the search did not end there, it evolved. Today, the quest to find extraterrestrial intelligence is a continuous, real-time scientific endeavor. Projects like Breakthrough Listen use some of the world's most powerful telescopes, from the Green Bank Telescope in West Virginia to the Parkes Observatory in Australia, to monitor millions of stars and galaxies. Their computers analyze a river of data, filtering out human interference like satellites and aircraft, hunting for that telltale narrowband signal or a repeating pattern that nature cannot forge. This modern search even had its own moment of profound intrigue in 2020. A signal named BLC-1 appeared to be coming from the direction of our closest stellar neighbor, Proxima Centauri. It was narrowband, it persisted, and it seemed to drift in frequency in a way consistent with a planet's motion. For a time, it checked many of the boxes. The excitement was palpable, but science demands rigorous proof. After months of analysis, the team traced it not to an alien world, but to human technology, likely a malfunctioning electronic device on Earth's surface. The story of BLC-1 is not a disappointment, it is a blueprint. It shows the meticulous process of modern SETI, where every candidate signal is put through a gauntlet of tests, and where the null result is just as valuable as a discovery. It proves the system is working, listening around the clock, So while the wow signal remains an isolated, enigmatic event, the silence that followed is not empty. It is filled with the hum of servers in control rooms, the slow sweep of gigantic dishes against the stars, and the quiet hope of scientists who know that the next signal could arrive at any moment. We are all waiting for the cosmos to speak again. While we listen for signals from the stars, a chaotic ballet is unfolding much closer to home. Beyond Neptune, the dwarf planet Pluto is not a solitary world, but the center of a gravitational frenzy. Its largest moon, Charon, is so massive that the two actually orbit a point in the space between them, making Pluto and Charon a binary system. This intimate, lopsided dance sets the stage for pure orbital chaos. The four smaller moons, Styx, Nix, Kerberos, and Hydra, do not follow simple, predictable paths. Instead, they are caught in a complex, interwoven gravitational tug of war between Pluto and Charon, a dance that is actively playing out right now. Data from the New Horizons spacecraft revealed this system in stunning, bewildering detail. The orbits of these tiny moons are not neat circles, but are tilted and eccentric, wobbling like unbalanced tops. Most astonishingly, the moons Nix and Hydra are in a state of pure chaos. Their rotations are not locked, they tumble unpredictably, their poles and equators shifting wildly over time. If you stood on the surface of Nix, you would not have a consistent day or night. The sun would rise and set at random points on the horizon, in a sky where both Pluto and the giant Charon would perform their own dizzying arcs. This is not a theoretical prediction, it is a current, measurable fact of their orbital mechanics. The reason for this pandemonium lies in the heart of the double planet. The gravitational pull from both Pluto and Charon creates what scientists call overlapping resonances. Imagine pushing a child on a swing. If you push at the exact right rhythm, the swing goes higher smoothly. But if you and a friend push at slightly different competing intervals, the motion becomes jerky and unpredictable. That is the environment for Pluto's small moons. The competing gravitational kicks from the binary pair prevent them from settling into a stable rhythm, forcing them into their chaotic tumble. This ongoing dance is a direct challenge to our classical understanding of orbital stability. For centuries, we modeled planetary systems with neat clockwork precision. Pluto's moon system is a living laboratory showing that such precision can be an illusion, that gravitational systems with multiple large bodies can inherently produce chaos. It also tells a violent story about Pluto's past. Astronomers believe this entire arrangement is the aftermath of a cataclysmic collision billions of years ago, similar to the impact that formed our own moon. A large object likely smashed into a young Pluto, spraying debris into orbit. That debris first coalesced into Charon, and the remaining fragments, under the complex gravitational influence of the new binary, slowly gathered to form the four smaller, tumbling moons we see today. Their irregular, potato-like shapes captured in New Horizons images are frozen testaments to that violent birth and their never-settled lives. So while we often picture the solar system as a place of order, Pluto reminds us that chaos is woven into the fabric of gravity itself. A small, frozen world hosting a storm of orbital anarchy that continues with every passing second. That chaotic gravitational dance at the solar system's edge is a testament to impermanence, a quality shared by one of our sky's most iconic sights. Saturn's rings are not a static, eternal halo. They are a dynamic, violent, and fleeting storm of ice happening right now. The Cassini spacecraft did not just photograph their beauty, it plunged through them, tasting their composition and listening to their whispers. It found a realm of pure chaos where particles ranging from dust grains to mountain-sized boulders are in a constant, silent collision, shepherded by the gravitational nudges of Saturn's many moons. The rings are almost pure water ice, glittering because they are constantly shattered and refreshed by impacts. Yet for all their grandeur, they are an illusion of permanence. Cassini's final, daring orbits revealed a startling truth. the rings are dying. A slow but steady drizzle of icy particles, pulled by Saturn's magnetic field and gravity, is raining down into the planet's upper atmosphere. Scientists call it ring rain. This is not a metaphor. Instruments detected the faint but unmistakable signature of this infall, a shower of ice and dust from the inner edge of the rings, falling at a rate that could fill an Olympic swimming pool every day. This process has been ongoing since the rings formed, and it gives them an expiration date. Based on the current rate of loss, astronomers estimate the rings may be gone in just a few 100 million years. In the lifetime of our solar system, that is a blink. It means the rings we see today, the defining feature of Saturn, are a temporary spectacle. We are cosmically lucky to be here during their brief, brilliant reign. Their youth adds to the mystery. For a long time, we assumed the rings were as old as the planet itself, over 4 billion years. But data from Cassini suggests they are likely a recent acquisition, perhaps only 100 million to 200 million years old. This implies a dramatic, violent birth. The leading theory is that a former moon of Saturn, or perhaps a large comet, strayed too close and was torn apart by the planet's immense gravity. The shattered remains were then ground into the brilliant, broad disk we see today. So when you look at Saturn through a telescope, you are witnessing both a crime scene and a countdown. You see the glittering debris field from an ancient cataclysm, a structure that is actively eroding before our eyes, destined to vanish into the planet's clouds. It is a powerful reminder that even the most majestic features of our cosmos are transient, caught in a beautiful, silent downpour that will one day leave Saturn looking strangely, vulnerably bare. The silent erosion of Saturn's rings is a gentle cosmic rain, but the Sun delivers storms of a far more violent nature. Our star is not a placid ball of light, it is a churning, magnetic cauldron, and its weather directly shapes our technological world. Right now, the Sun is approaching the peak of its 11-year cycle of activity, a period where its surface grows increasingly tempestuous. This means more frequent and more powerful solar storms, events that are not distant curiosities but genuine threats unfolding in real time. The most dramatic of these are coronal mass ejections. Imagine the Sun's magnetic field lines, twisted like rubber bands by the star's rotation, suddenly snapping and reconnecting. This releases a titanic amount of energy, often accompanied by a brilliant flash of X-rays called a solar flare. But the real danger comes next. The reconnection can blast 1 billion tons of superheated plasma, a cloud of charged particles, directly into space at millions of miles per hour. If Earth lies in the path of that cloud, the consequences can be profound. We are protected by our planet's magnetic field, which acts as a shield, deflecting most of this solar wind. But during a direct hit from a massive coronal mass ejection, the magnetosphere can be severely compressed and stressed. Induced currents surge through long conductors on the ground, like power lines and pipelines. The most famous example is the Carrington event of 1859, a solar superstorm so powerful it caused telegraph systems across Europe and North America to fail, with operators reporting sparks flying from equipment and papers catching fire. A storm of that magnitude today would be catastrophic. It could trigger widespread, prolonged power grid failures, disable satellites that govern global communications and GPS, and pose severe radiation risks to astronauts and even passengers on high-altitude flights. The entire infrastructure of modern life is vulnerable to this invisible space weather. This is not speculative fiction, it is a monitored risk. A global network of observatories like the SOHO and SDO satellites keeps a constant, vigilant eye on the Sun. They provide the data for space weather forecasts, giving satellite operators and power grid managers precious hours, sometimes days, of warning to take protective measures, like putting satellites in safe mode or adjusting grid loads. We are living in a period of increasing solar fury, a reminder that our greatest source of light and life is also a capricious neighbor. capable of reminding us of our fragility with a single billion-ton blast. The sun's storms are a present danger, but the deepest mysteries often lie in the quietest, coldest places, far beyond the orbit of Neptune, in a region of perpetual twilight called the Kuiper Belt. A group of icy wanderers is telling a story we cannot yet fully understand. These are not ordinary comets or asteroids. They are extreme trans-Neptunian objects, and their paths through the dark are whispering of a hidden presence. Right now, as they trace their million-year orbits, these distant bodies are exhibiting a bizarre gravitational signature, a clustering of their orbits that defies the simple pull of the known planets. Imagine you threw a handful of marbles onto a vast, flat table. You would expect them to scatter randomly, pointing in all directions. But if you came back and found every single marble had rolled to one specific corner and was tilted at the same odd angle, you would know something was wrong. The table itself must be tilted, or there is a hidden magnet beneath the surface. That is precisely the puzzle astronomers face with these ETNOS. Their elongated orbits are not randomly oriented in space. Instead, their closest approaches to the Sun are mysteriously bunched together, and the planes of their orbits are tilted in a similar direction, as if an unseen hand is gently herding them. This peculiar alignment is the primary evidence for the hypothetical Planet 9, a world with up to 10 times Earth's mass on a monstrous elliptical path. The gravitational tug of such a distant giant could, over eons, shepherd these smaller objects into the strange configuration we observe. But Planet 9 is not the only possible shepherd in the dark. Some theorists have proposed an even more exotic possibility, a primordial black hole. This would not be the stellar mass black hole from a dead star, but a fossil from the universe's first second, a tiny, city-sized object with the mass of a planet, captured by our sun's gravity long ago. Its gravitational influence would be identical to a planet of the same mass, but it would be utterly dark and nearly impossible to detect except through its effects on these distant orbits. Then there is the simplest yet most scientifically unsatisfying explanation, a statistical fluke. Could we, by sheer chance, have discovered the only handful of objects that happen to be aligned, while thousands of others with random orbits remain unseen? This is the constant tension in cutting-edge astronomy between a thrilling discovery and a trick of limited data. This is why the hunt is so active and urgent. Every new extreme trans-Neptunian object discovered, often as just a single, slow-moving pixel of light in the deepest telescope images, is another data point. Astronomers are using these new discoveries to refine the possible orbits of the hidden perturber, whether it is a planet or something stranger. Each new object either strengthens the clustering signal or begins to scatter it, guiding the search. Powerful survey telescopes scan the predicted hiding places, looking for that faint, moving dot. The distant Kuiper Belt, once thought to be a sparse and quiet repository of ancient ice, is now a cosmic crime scene. The aligned orbits of these distant objects are the clues, the gravitational fingerprints of a suspect that has yet to be seen. We are piecing together the evidence in real time, knowing that the next discovery could either solve the mystery or deepen it beyond our wildest imagination. At the very heart of the Milky Way, a monster sleeps. It is not a myth, but a scientific fact, a supermassive black hole named Sagittarius, a star. This invisible titan, containing the mass of 4 million suns, is the silent anchor around which our entire galaxy spins. But its silence is deceptive, for this is an active and occasionally temperamental beast. For decades, astronomers have watched its immediate neighborhood, a region of space smaller than our solar system, using infrared telescopes to peer through the galactic dust. What they see is a gravitational racetrack of epic proportions. Stars like the one known as S2 are not placidly orbiting. They are being whipped around at speeds exceeding 15 million miles per hour, tracing elongated loops that bring them breathtakingly close to the point of no return. These stars are live action probes testing the very fabric of space-time. Their orbits precisely follow the predictions of Einstein's theory of general relativity, their paths warping in ways Newtonian gravity could never explain. Watching them is like witnessing a real-time experiment on cosmic scales, confirming that we live in a curved, dynamic universe. The environment here is one of pure, violent potential. Gas clouds are stretched into thin streams, and the very fabric of space is warped by the black hole's immense gravity, and sometimes the monster stirs. In May of 2019, Sagittarius, a star, did something unprecedented. It suddenly flared, becoming 75 times brighter than usual in infrared light for a brief, chaotic period. This was not a gentle flicker, but a violent eruption. The leading theory suggests a hapless asteroid or gas cloud may have ventured too close, its material torn apart and heated to incandescent fury as it spiraled into the abyss. It was a stark reminder that this sleeping giant is capable of sudden, violent awakenings. Then, in 2022, humanity was granted its first direct visual evidence of this cosmic phantom. The Event Horizon Telescope collaboration unveiled an image not of the black hole itself, for no light can escape it but of its shadow, a dark silhouette encircled by a brilliant, lopsided ring of superheated gas swirling at near light speed. That orange donut of light, a landmark achievement in science, is the outline of the monster's lair. It is a portrait of gravity so intense it bends light into a perfect circle. So when you look toward the constellation Sagittarius, know that you are gazing toward the center of our galactic whirlpool, where stars dance on the edge of oblivion and an invisible behemoth occasionally opens a fiery eye, reminding us of the dynamic, violent heart that powers our island universe. The monster at our galaxy's heart anchors a vast system, but sometimes visitors arrive from far beyond its gravitational reach. In October of 2017, astronomers spotted a cosmic interloper, a tiny point of light moving far too fast to be bound to our sun. It was named Oumuamua, Hawaiian for scout, and it was our first confirmed visitor from another star system. Its brief passage through our solar system left behind more questions than answers, sparking a debate that continues to this very day. The object was bizarre from the start. Its brightness varied dramatically, suggesting it was tumbling end over end and had an extremely elongated shape, perhaps 10 times longer than it was wide, like a cosmic cigar or a pancake. But the true mystery came as it sped away. Its trajectory could not be explained by the sun's gravity alone. It was accelerating as if pushed by an unseen force. For comets, this is common, caused by outgassing, the sun heating icy material that jets out like a rocket engine. Yet Oumuamua showed no visible coma, no tail of gas and dust that telescopes could detect. This missing tail led to a fierce scientific argument. One camp proposed it was a comet after all, but one made of very unusual ices like solid nitrogen or hydrogen that could vaporize without leaving a visible dust trail. The other camp, led by Harvard astronomer Avi Loeb, suggested the acceleration could be due to radiation pressure from sunlight on an object that was extremely thin and light, perhaps a solar sail of natural or even artificial origin. While the alien technology idea remains a highly speculative minority view, it highlighted just how strange our first interstellar guest truly was. Before the debate could settle, the cosmos sent us a second, clearer postcard. In August of 2019, an amateur astronomer named Gennady Borisov discovered a new comet. Its trajectory soon revealed it, too, was an interstellar traveler named 2I Borisov. Unlike Oumuamua, this visitor was unmistakably a comet. It developed a brilliant classic tail of gas and dust as it neared the sun, a familiar sight with an extraordinary origin. Its composition was studied in detail, revealing it was born around a star very different from our own, enriched in carbon monoxide. These two objects, the strange rocky shard and the classic icy comet, prove that interstellar space is not empty. It is filled with debris ejected from other solar systems, a cosmic flotsam and jetsam drifting between the stars. Current estimates suggest there could be thousands of such objects within the orbit of Neptune at any given moment, most too faint for our current telescopes to see. That is about to change. New observatories like the Vera C. Rubin Observatory in Chile will soon begin scanning the entire sky with unprecedented depth and frequency. It is expected to detect dozens, perhaps hundreds, of these interstellar nomads every year. Each one will be a pristine sample from a distant alien star system, a chance to study the building blocks of other worlds without ever leaving our own. So the legacy of Oumuamua is not a single answer, but an opening of a new frontier. We now know our solar system is a busy crossroads with silent travelers constantly passing through. The next one could be another tumbling rock, a spectacular icy wanderer, or perhaps something even stranger waiting in the dark for our telescopes to find it. That silent traffic of interstellar visitors hints at a cosmos far more interconnected than we knew, but another mystery suggests those connections may stretch beyond reality itself. Hundreds of galaxy clusters, the largest gravitationally bound structures in existence, are not moving at random. They appear to be streaming together in a coherent, high-speed flow toward a single patch of sky, as if pulled by a force of unimaginable power from beyond the edge of everything we can see. This is the phenomenon called dark flow, and if it is real, it is not just bizarre, it is a fundamental challenge to one of cosmology's bedrock principles. For over a century, we have operated on the cosmological principle, the idea that on the largest scales, the universe is homogeneous and isotropic. It looks roughly the same in every direction, with no special place or center. The dark flow observation, first detected by studying the subtle distortions in the cosmic microwave background left by moving clusters, seems to violate this. It suggests a preferred direction in the cosmos, a cosmic current flowing toward something we cannot see. The speed of this flow is staggering, hundreds of kilometers per second, and it involves clusters billions of light years apart. The gravitational pull required to move such immense structures must come from something truly colossal, something whose mass lies outside our observable horizon. This leads to the most profound and controversial interpretation. The source of the pull could be something from another universe. In some models of a multiverse, our universe is one bubble in an infinite froth of other bubble universes, each with its own physical laws. If another bubble universe happened to collide with or pass extremely close to ours in the greater multiverse, its gravitational influence could theoretically reach into our cosmic domain, tugging on our galaxy clusters from beyond the veil. We would feel its pull without ever being able to see the source, like feeling a breeze from a door in a dark room we did not know was there. Unsurprisingly, this idea is hotly contested. Many astronomers question the statistical significance of the dark flow signal, arguing it could be an artifact of incomplete data or systematic errors in measurement. The cosmic microwave background is incredibly faint, and extracting such a subtle signal from it is a monumental task ripe for misinterpretation. The scientific process is now a tug of war between teams reanalyzing the data with newer instruments and refined methods. Some subsequent studies have failed to confirm the original detection, while others claim to see hints of it persisting. This ongoing controversy is not a failure of science, but its very engine. It is the sound of the frontier being tested. Whether dark flow is ultimately confirmed or refuted, its very proposal forces us to confront the limits of our knowledge. It asks us to consider that the grand stage of our observable universe, all 93 billion light years of it, might itself be just a local neighborhood, subject to tides and currents from a reality so vast it defies description. So this cosmic stream, if it exists, is more than just moving galaxies. It is a potential clue written in the motion of the largest things we know, a whisper that our entire cosmic bubble might be drifting in a sea of other realities, pulled by a gravity from beyond the edge of all light. Our nearest stellar neighbor is a violent place. Proxima Centauri, the red dwarf star just over 4 light-years away, is home to a tantalizing world, Proxima b, a planet roughly Earth's mass sitting within its star's habitable zone where temperatures could allow for liquid water. But in May of 2019, Proxima Centauri did something that shattered any idyllic vision of that world. It erupted. In a span of just 7 seconds, the star unleashed a superflare, a cataclysmic burst of energy that made it 14,000 times brighter in ultraviolet light. For a fleeting moment, our closest stellar neighbor became a cosmic blowtorch, and its potentially habitable planet was directly in the line of fire. Light curves from observatories around the world captured the event, graphing a sudden, terrifying spike in brightness against the star's normally quiet baseline. If you could have seen it, the flare would have appeared as a brilliant, blinding flash, a stellar tantrum of epic proportions. This was not a one-time event. Red dwarf stars like Proxima Centauri are notoriously tempestuous, especially in their youth. They possess strong, tangled magnetic fields that frequently snap and reconnect, releasing these monstrous flares and bathing their planetary systems in intense radiation. For a planet like Proxima b, orbiting 20 times closer to its star than Earth does to the Sun, the consequences are severe. The superflare of 2019 likely delivered a blast of X-rays and ultraviolet radiation thousands of times more intense than anything Earth receives from our Sun. Imagine the planet's atmosphere, if it has one, being violently stripped away molecule by molecule by the stellar wind supercharged by that eruption. Any potential oceans could have been flash-heated, their chemistry altered. On the surface, the flare would have delivered a lethal dose of radiation to any life not deeply shielded beneath rock or ice. This single event highlights the profound paradox of red dwarf habitable zones. These stars are long-lived and plentiful, making their planets prime candidates in the search for life. Yet their violent youth and frequent flaring may sterilize worlds before life ever gets a foothold. Proxima b's story is not over, however. Some models suggest that if a planet has a strong magnetic field like Earth's, it could deflect much of the stellar wind and protect its atmosphere. Or if the planet started with a thick, primordial hydrogen envelope, it might withstand the erosion. Life, if it exists, would almost certainly need to be subterranean or aquatic, hidden from the frequent radioactive downpours. The flare from 2019 is a powerful, sobering data point. It tells us that the search for life is not just about finding a planet at the right distance for liquid water. It is about understanding the entire life story of a star and its capacity for violence. We are witnessing, in real time, the environmental forces that shape alien worlds, forces that can both create and destroy the conditions for life in a single, brilliant flash. That violent flash from a nearby star is a local drama, but the entire cosmic stage itself is stretching, growing larger every second. The universe is not static, it is actively expanding, and this expansion is not slowing down, it is accelerating. Right now, the very fabric of space between galaxies is stretching, carrying them away from each other at a speed that increases with time. This is not a theory about the distant past, it is a measurable fact of the present moment, confirmed by observing the light from distant supernova. To visualize this, think of a loaf of raisin bread rising in the oven. The raisins are like galaxies, and the dough is the fabric of space. As the dough rises, every raisin moves away from every other raisin. No single raisin is the center, but from any raisin's perspective, all the others are receding. That is precisely what is happening to our cosmos, but with a strange and crucial twist. The oven is getting hotter, making the dough rise faster and faster. This accelerating expansion is the greatest surprise in modern cosmology, and its cause is the deepest mystery we have ever faced. We call that cause dark energy. It is not a substance we can touch or see, but a property of empty space itself, a kind of anti-gravity that pushes the universe apart. The best measurements tell us that dark energy makes up about 68% of everything in the universe. It is the dominant force shaping the cosmos's ultimate fate, and we have almost no idea what it actually is. The simplest idea is that it is a constant energy woven into the vacuum of space, an intrinsic push that never diminishes even as space grows. Other theories suggest it could be a dynamic field that changes over time, or even a sign that our understanding of gravity itself is incomplete on the largest scales. The consequences of this unending acceleration are profound and, in a cosmic sense, lonely. As space stretches faster and faster, the distance between galaxy clusters will eventually grow at speeds greater than light can travel. This does not violate the law that nothing moves through space faster than light, because it is space itself that is expanding. The result is a future where, billions of years from now, galaxies outside our local group will have sped beyond our cosmic horizon. Their light will no longer be able to reach us. The sky will grow dark, not of stars, but of other islands of stars. Our descendants, if any remain in this far future Milky Way, will look out upon a void with only a handful of nearby, merged galaxies for company. The universe will become a collection of isolated archipelagos in an ever-widening sea of nothingness, growing cold and dark as stars slowly burn out. We are living in a brief, golden age of cosmology, a window in time where the afterglow of the Big Bang is still visible and distant galaxies are still within sight. We can measure this great acceleration and ask the fundamental questions it poses. What is the true nature of the vacuum of empty space if it contains this immense repulsive energy? The expansion of the universe is the backdrop for every other bizarre event, the canvas upon which all cosmic stories are painted, and its accelerating pace is the most significant and most mysterious process happening in the cosmos right now. The relentless expansion of space is a slow cosmic tide, but some events compress the power of the universe into a single, shattering instant. Across the darkness, city-sized corpses of dead stars are spiraling toward a violent reunion. These are neutron stars, the densest objects we know, forged in the supernova explosions of massive suns. A single teaspoon of their material would weigh 1 billion tons on Earth. They are the universe's ultimate diamonds, unimaginably hard and heavy. And when two of them, locked in a final gravitational dance, finally merge, they unleash a cataclysm so brilliant and powerful it forges the very elements that make up our world. This event is called a kilonova, and it is the universe's most spectacular alchemical furnace. For billions of years, a pair of neutron stars can orbit each other, slowly losing energy by rippling the fabric of spacetime itself. These ripples are gravitational waves predicted by Einstein a century ago. As the stars lose energy, their orbit tightens, their dance accelerates from a stately waltz to a frantic final pirouette. In the last milliseconds, they spiral inward at nearly the speed of light, finally colliding. The impact is beyond comprehension. It releases more energy in a fraction of a second than our Sun will emit in its entire 10 billion-year lifetime. The collision creates a blinding flash of light across the electromagnetic spectrum, from gamma rays to radio waves, a transient firework known as a kilonova. But the true magic is not in the light show, it is in what is forged in that unimaginable heat and pressure. For most of cosmic history, the universe was a relatively simple place, filled with hydrogen, helium, and a smattering of lighter elements. The cores of stars fused elements up to iron, but creating anything heavier required something more extreme. A kilonova is that cosmic crucible. In the neutron-rich debris ejected from the collision, atoms are bombarded with a torrent of free neutrons in a process called rapid neutron capture. This is how the universe manufactures gold, platinum, uranium, and other heavy elements. The gold in your jewelry, the platinum in a catalytic converter, were likely born in the fiery aftermath of a neutron star collision that occurred billions of years ago before our solar system even formed. We are literally made of stardust, but our most precious metals are forged in stardust's most violent funeral. For decades, kilonovae were purely theoretical. Then, on August 17, 2017, everything changed. Gravitational wave observatories LIGO and Virgo felt a distinctive ripple in spacetime, a signature unlike any black hole merger. Just seconds later, space telescopes detected a corresponding flash of gamma rays from the same patch of sky. The race was on. Astronomers around the world swiveled their telescopes to the constellation Hydra, and there they saw it, the first confirmed kilonova. They watched its light change color over days, from blue to red, exactly as models predicted for an expanding cloud of heavy radioactive elements. It was a triumph of multi-messenger astronomy, where we not only heard the universe's space-time shudder, but saw the brilliant aftermath with our own eyes. This means the cosmic foundry is active. Right now, in galaxies near and far, these incredibly dense remnants are winding down their final orbits. Each merger we detect is a live broadcast of elemental creation, a real-time demonstration of how the universe populates itself with the building blocks of planets and ultimately life. The gravitational waves from these events are a new sense for humanity, allowing us to feel the vibrations of the cosmos. Every signal is a direct message from one of the most energetic processes in existence, a reminder that even in the cold void, there are factories of incredible violence, tirelessly forging the seeds of future worlds. While neutron star collisions forge elements across the cosmos, one of humanity's own creations is currently writing a new chapter much closer to home. A spacecraft named Parker Solar Probe is performing a feat of engineering so audacious it redefines exploration. Right now, it is not just orbiting the Sun, it is diving directly into its atmosphere, repeatedly plunging through the million-degree corona itself. This is not a distant observation, it is a live, tactile investigation of our star, a mission that is actively rewriting solar science with every perilous loop. Launched in August 2018, the probe was built for one purpose: to touch the Sun. Its journey is a carefully calculated dance with gravity, using repeated flybys of Venus to gradually tighten its orbit, swinging it closer and closer to the solar inferno. With each pass, it sets a new record, becoming the fastest human-made object ever and the closest spacecraft to a star. The conditions it faces are beyond extreme. At its closest approach, the probe endures temperatures exceeding 2,500 degrees Fahrenheit, with its carbon composite heat shield facing the full, unfiltered fury of our star. The sunlight here is over 500 times more intense than what we experience at Earth. To survive, the spacecraft relies on a revolutionary heat shield, a lightweight, white ceramic coating that reflects the immense radiation, keeping the sensitive instruments tucked safely in its shadow at a relatively balmy 85 degrees Fahrenheit. But the heat is only part of the challenge. The probe is flying through the birthplace of the solar wind, that stream of charged particles that shapes space weather and can disrupt our technology. For decades, a fundamental mystery has puzzled scientists. Why is the Sun's corona, its outer atmosphere, millions of degrees hotter than the visible surface below? It defies basic intuition, like walking away from a campfire and feeling the air get hotter, not colder. Parker is providing the first direct measurements from this region, and the data is full of surprises. It has detected sudden, violent reversals in the Sun's magnetic field, events nicknamed switchbacks. These are like giant, S-shaped kinks in the magnetic field lines that whip out from the Sun at incredible speeds, carrying energy and likely playing a key role in heating the corona and accelerating the solar wind. The probe has also directly sampled the dust-free zone around the Sun, a region where intense heat vaporizes cosmic dust, confirming a century-old prediction. Each orbit, as it screams through the corona at nearly 430,000 miles per hour, its instruments taste the plasma, map the magnetic fields, and count energetic particles in real time. This data streams back to Earth, offering a ground truth that remote telescopes could never provide. We are no longer just watching the sun from a safe distance. We are flying a laboratory through its stormy atmosphere, feeling its magnetic texture and tracing the origins of the very wind that shapes our cosmic environment. The Parker Solar Probe transforms a passive celestial body into an active, dynamic frontier. It is a human-made comet, its path a deliberate fall into a fire, and with each daring dive, it sends back postcards from a place we once thought was forever beyond our reach. Each new orbit of the Parker probe feels the sun's breath, but another eye is looking outward, seeing the universe in a light we have never witnessed before. The James Webb Space Telescope is not merely an observatory, it is a time machine and a chemical analyzer of unparalleled power, and its discoveries are actively rewriting our cosmic story in real time. Perched a million miles from Earth, its golden honeycomb mirrors are currently collecting photons that have traveled for over 13 billion years, light from the universe's first generations of stars and galaxies. What it is finding there is not just ancient, it is profoundly puzzling. The early universe, as seen by Webb, is not a sparse, primitive place. It is already crowded with massive, mature galaxies, gleaming cities of stars that appear far too soon after the Big Bang. According to our best models, these colossal structures should not have had enough time to assemble. It is like walking into a forest you planted just a decade ago and finding fully grown, 1,000-year-old oak trees. This single, persistent observation is sending cosmologists back to their drawing boards, questioning the timeline of cosmic evolution itself. The telescope's power extends from the impossibly distant to the tantalizingly close. It is now turning its gaze toward the atmospheres of distant exoplanets, not as blurry dots but as chemical laboratories. By capturing the starlight that filters through a planet's air as it passes in front of its star, Webb can dissect that light into a spectrum, a barcode of absorption lines that reveals the fingerprints of molecules. It has already detected water vapor, methane, and carbon dioxide in alien skies. The next step, already underway, is the hunt for a potential biosignature, a chemical imbalance like the simultaneous presence of oxygen and methane that on Earth is maintained by life. Every new observation of an exoplanet atmosphere is a live chemical analysis of a world dozens of light years away. And then there are the sheer portraits of cosmic beauty that are also maps of violent creation. Webb's images of the Carina Nebula or the Pillars of Creation are not just pretty pictures. They are infrared visions that pierce through obscuring dust, revealing stellar nurseries where new suns are igniting, and the fierce stellar winds from newborn giants that are simultaneously sculpting and eroding the cosmic landscape. Every transmission from the telescope is a data dump of astonishment. A single week can bring a galaxy that breaks the early universe record, a new detail in a dying star's nebula, or a complex molecule identified around a forming planet. Textbooks are not being updated yearly, but monthly, as the steady stream of data challenges old assumptions and poses new, sharper questions. This is not history, it is current events on a cosmic scale. The James Webb Space Telescope is our collective eye, open wider than ever before, watching the universe's deepest past and most intriguing presence unfold simultaneously, ensuring that the greatest discoveries are not behind us but happening right now. From the runaway black hole forging stars in its wake to the silent drizzle eroding Saturn's rings, this is a cosmos in constant, breathtaking motion. We have witnessed 25 events that are not relics of a distant past, but processes unfolding in the present moment, a live broadcast from a universe that is stranger, more violent, and more creative than we ever dared to imagine. These are not isolated curiosities, they are interconnected threads in a single grand tapestry. The same gravity that hurls distant planets into strange orbits also whips stars around our galactic center. The same magnetic fury that sparks solar storms may power the enigmatic flashes of distant magnetars. Each mystery solved reveals 10 new questions, and that is the true engine of discovery. This relentless, dynamic activity is the background of our existence. We are not passive observers on a quiet stage. We are participants in a grand, evolving story. The gold in a wedding ring was forged in a cataclysm billions of years ago. The air we breathe was recycled through generations of stars, and the ground we walk on is a testament to the chaotic construction of our solar system. Every glance at the night sky is a look into an active workshop, a laboratory of physics operating on a scale that both humbles and inspires. Let these ongoing wonders reframe your perspective. The next time you see the steady glow of a star, remember it might be a red giant like Betelgeuse quietly ticking toward a spectacular end. When you spot the faint smudge of the Andromeda galaxy, know you are looking at a future partner in a slow-motion dance of destruction and rebirth. The universe is not static, and neither is our understanding of it. Our tools, from the Parker Solar Probe braving the sun's corona to the James Webb Space Telescope peering into the cosmic dawn, are extending our senses into the void, turning whispers of data into shouts of revelation. This journey does not end here. New mysteries are being recorded by telescopes every night, waiting for a curious mind to piece them together. So keep looking up. Let the vast, active strangeness of the cosmos fill you with wonder and drive your own curiosity. Ask questions, seek out the stories written in the light, and remember that you are living in a golden age of exploration where the greatest discoveries are happening right now. If you want to continue exploring these wonders with us, be sure to subscribe. The universe has countless more stories to tell, and we are just beginning to listen.